In this video, we are going to look at another implicit differentiation example, but I'm going to up the difficulty this time from that last video, or the last example that we looked at. So let's consider the curve given by the equation e to the y to the 4 minus 6x squared y equals e minus 24. And what I want to do is find the equation of the tangent line at the point 2, 1. So in the last video, we did an example in which we actually showed 3 methods for doing it. One involved geometry, one involved isolating the y and writing y explicitly in terms of x, and then taking the derivative. And the final method was implicit differentiation. With this equation right here, it is actually impossible to isolate y. Impossible to isolate y. And because of that, we must differentiate implicitly. Differentiate implicitly. Implicitly. Okay. So we begin that by taking the derivative of both sides. So in this case, we want to take d dx of both sides. Because if our goal is to find the equation of a tangent line, at some point we're going to need dy dx, because dy dx will tell us the slope of the tangent line. So to get there, I'm going to have to take the derivative of both sides first. So doing that, I'll write d dx of the left, e to the y to the 4, minus 6x squared y, and then this equals d dx of the right, so d dx of e minus 24. Okay. So when we take the derivative of e to the y to the 4, we see e to the stuff here. It's not just e to the x, it's e to the something more complicated. So that's going to involve chain rule. The derivative of e to the stuff it's e to the stuff, in this case is e to the y to the 4, but then we multiply that by the derivative of the stuff. In this case, the exponent is y to the 4. Alright, so as we get more comfortable with these, we'll start to just write down that derivative on the same line rather than spreading it out over multiple lines. But because we're just introducing this, I really want to show those steps. Okay, so now let's go to the next term. So now I have to take the derivative of this minus 6x squared y term. So for the minus 6x squared y, the minus sign, let's just keep that out in front. And then let's take the derivative of 6x squared y. And for that derivative, let's use the product rule, because I see two things multiplying each other. I see 6x squared is sort of multiplying the y. So the product rule says, well, write down, let me put a big bracket around this, because the minus sign is going to apply to this whole thing, to 6x squared y. So it's going to apply to the whole product rule thing that we get. Okay, so product rule says take the first function, which is 6x squared, multiply that by the derivative of the second. So multiply that by the derivative d dx of y. And then plus the second, so plus y, times the derivative of the first. So times d dx. And the first function was 6x squared. Okay, so that finishes my product rule. And so at least that finishes all the terms of my product rule. Okay, so now we need the derivative of the right-hand side. Well, e minus 24 is a constant. So its derivative is 0. All right. So there are a few derivatives now left to do. There's a derivative of y to the 4th, and there's a derivative of y. So remember, the way I deal with something like this, the derivative of y to the 4th, when we do implicit differentiation, we think of y as being a function of the other variable. In this case, it's x. So we're actually taking the derivative of something that we're thinking of as being like y of x, thinking of y as a function of x, to the 4th power. And that's chain rule. Chain rule says deal with the outside first, deal with that power. Power comes down, and then you'll subtract 1 from the power, you'll get a 3. And when we do the derivative of the outside, we keep the inside the same, so keep plugging in y of x. But then the next part of chain rule says we'll multiply this whole thing by the derivative of the inside. So multiply it by dy dx, by the derivative of the inside. Okay, and if I just simplify this, if I just rewrite the y of x as y, this is 4y cubed dy dx. So the derivative, d dx of y to the fourth ends up just being 4y cubed times dy dx. Okay, so more and more now with these implicit differentiation questions, when we start to see them, when I see something like this, d dx of y to the fourth, usually I'm going to go straight to this line rather than going through all of these intermediate steps where I rewrite y as y of x and then go through that. But if it helps, we can definitely do all of those steps anytime. Okay, so let me talk through it. So we have this e to the y to the 4. And then for the derivative of y to the 4, what happened was we have to do chain rule. We have to do chain rule anytime we're taking the derivative of something with a variable like y. But when we're taking the so let me say it like this. We have to do the chain rule when we take the derivative with respect to a variable. In this case, because we're doing d dx, I'm taking the derivative with respect to the variable x. When that variable down here is different than the variable that appears here in my function, I need chain rule. So chain rule says first deal with the outside. And the outside is the fact that I have this 4, the power. So dealing with the power, we bring that power down, and then I subtract 1 from the power, so I get a 3. But chain rule says, okay, when you do that, keep plugging the same inside thing in. And what's inside is y. So that's the first part of the chain rule. And the next part of the chain rule says, well, multiply this by the derivative of the inside. The derivative of the inside, because we're taking d dx of y, the way we write what the derivative of y is with respect to x is we write dy dx. Okay, so I kind of just talked through these steps over here, but showing how I would jump straight from the beginning to the end. All right, so let's keep going. All right, so we have this whole thing minus, and then in brackets, we have 6x squared. So d dx of y is dy dx. That's how we write the derivative of y with respect to x. And then after that, we have plus y times d dx of 6x squared. Okay, so the derivative of 6x squared, that's just 12x. That's just a normal derivative. And this equals 0. So at this point, we have taken the derivative of both sides. Now we are ready to plug in the point that it tells us about. So now let's plug in that point, which is 2, 1. All right, so an important thing about plugging in. So just like with the derivative problems that we saw before we did implicit differentiation, when you want to find the slope of the tangent line at a certain point, you have to do the derivative first and then plug in the point. We can only plug in the point after taking the derivative. If we had tried plugging in from the beginning, if we had plugged 2 and the 1 in for the x and the y respectively in the beginning, we just would have gotten constants on both sides. We just would have had a number on the left and a number on the right. So taking the derivative would just give us 0 on both sides, and that's not helpful. So we want to take the derivative first, then plug in. So if we do that, if we plug these values in, we are going to get e to the 1 to the 4th times 4 times 1 cubed dy dx minus, and then we get 6 times 2 squared dy dx. And then plus, so y was 1 times 12x, and x was 2. All right, so this equals 0. So continuing to simplify, okay, so 4 times 1 cubed, that's 4. And then we have e to the 1, which is just e. So we have 4e dy dx. Okay, so that was not too bad, I think, there in the beginning. And then we have this negative sign, so let's distribute that negative sign in. I'm going to get minus 6 times 2 squared is 24, so minus 24 dy dx. And then we're going to have minus 24, so minus 24 equals 0. All right, so now let's move the minus 24 over to the right and get all the dy dx terms on one side. If I factor out dy dx, we get dy dx times 4e minus 24. And now I'm one step away. Dy dx equals, let's divide by the thing in parentheses. We get 24 over 4e minus 24. All right, and we could simplify this a little bit. I could, if I keep the top as 24, the bottom I could factor a 4 out of it and be left with e minus 6. And now I could cancel on the top and the bottom. I could divide them by 4 and be left with 1 on the bottom and 6 on the top. So overall I get 6 over e minus 6. Alright, so that's my derivative. That's my derivative at this point 2, 1. But the problem said, well, tell me the equation. So I can't just stop at the slope. To get the equation, well, I know the slope. I know the slope. And I know a point. It was 2, 1. So we're ready for some point-slope form. So we're going to get y minus the y-coordinate, which was 1, equals the slope, which is 6 over e minus 6. And then times x minus the x value, which was 2. And that's our equation in point-slope form. Alright, and now let's end this video with part B of this example. So part B is going to be, now let's find a general formula for dy dx. So instead of just using the dy dx that we got at the specific point in part A, I want a general formula for dy dx. Alright, so we can use our work from the last problem here. We just have to go back to a step before we plugged in. Okay, so before we plugged in, that was, we're talking about up here. That's what before we plugged in. So if I take that and I write what that is down, we get 4y cubed e to the y to the 4 dy dx. And if I distribute the negative sign in, we get minus 6x squared dy dx minus 12xy equals 0. And now let's just do the same thing. Let's isolate all the dy dx terms and then move anything that doesn't have a dy dx onto the other side. So I'm going to move the minus 12xy to the right, and it becomes 12xy. And on the left, I can factor out, we have these two dy dx's. We can factor them out and get a dy dx factored out times, we'll have 4y cubed times e to the y to the 4 minus 6x squared. All right, now we divide by the thing in parentheses, and we get that dy dx equals 12xy divided by 4y cubed times e to the y to the 4 minus 6x squared. And that is our general formula for dy dx. So in terms of our goals, we have now done another example. So that was our second goal, to do another example. We upped the difficulty with this example a little bit. In the next video, we are going to do another example of implicit differentiation, but it's going to involve an application to price and demand and revenue.